Hi, I'm Mr. Parker and this is question 2 on the OCR Core 2 paper from June 2010. For more questions on this exam paper, click the link here or check in the video description. Question 2. Use the trapezium rule with 3 strips, each of width 3, to estimate the area of the region bounded by the curve y equals the cube root of 7 plus x, the x-axis, and the lines x equals 1 and x equals 10. Give your answer correct to 3 significant figures. So we've got our function y equals the cube root of 7 plus x, and it's going to be bounded by the lines x equals 1 and x equals 10, and we're going to split it up using 3 strips. I've drawn a sketch of the curve over here. You don't need this to answer the question, but it might help you to understand what's going on. So it's split into 3 strips. That's going to look something like this. And we're going to find the area of each of these trapeziums, and that'll give us an approximation for the area underneath the curve. So we've got this formula here from the formula book, and it's got a value h in, which is the height of each of these trapezia, and we can calculate that by doing b minus a over n. B minus a are just these 2 limits here. Now it actually gives us the answer for h. In the question it says each of width 3, but if it didn't give that, it'd be quite easy to work it out. We'd just do h equals b minus a, that'll be 10 minus 1, divided by the number of strips. Well, we've got 3, 10 minus 1, that's 9 divided by 3, which gives us 3. Okay, we don't have to do that because it tells us in the question, so we'll just say that h is 3. So in order to use this formula, we're going to need to know these values y0, yn, and so on. And we get those values by substituting into this formula values of x. So say we had a value of x down here, I'll call it x0. If we substitute that value into this formula here, we get a value y0 up here. And we're going to do that for each of these here. So x1 will give us y1, x2 will give us y2. It's a bit easier when you see it actually in practice. In order to make this formula easy to use, I'm going to draw a table to do most of the working out. So my values for x are going to go in this column, my values for y in this column, and I'm going to call this column the weight. So I'm going to start at 1, and I'm going to go up in strips of 3 until I get to 10. So I'm going to go 1, 4, 7, 10. So notice here I need 4 what are called ordinates in order to get 3 strips. I always need 1 extra. And to work out the y column, I'm going to substitute x into this formula for each one. So if I substitute 1 into this formula up here, I get 7 plus 1, which is 8, and I'm doing the cube root of 8, which is 2. If I substitute 4 in, 7 plus 4 is 11, that's going to give me the cube root of 11. If you can't get an exact value for something, leave it in its exact form. If I substitute 7 in, 7 plus 7 is 14, that gives me the cube root of 14. And if I substitute 10 in, 7 plus 10 is 17, that gives me the cube root of 17. To understand how to fill in this weight column, we need to look at the bit inside the curly brackets of the formula here. We've got this y0 and y1 in a bracket here, and that corresponds to the first and last values on our curve here at the intervals. And we're just going to add those together. But for all the other values, they get used twice. So if you consider y1, the value at this ordinate here, this one is going to be used to calculate the area of trapezium A and the area of trapezium B. The same with y2, it's going to be used for B and for C. So we end up doubling those values in here, and we're going to do that in our table so we've got less to do at the end. So y0 and y1, the first and last values, so 1 and 10, they stay the same. So I'm just going to write 2 and the cube root of 17 in here. But the ones in the middle, they're going to be multiplied by 2. So I get 2 lots of the cube root of 11 and 2 lots of the cube root of 14. So this whole calculation inside this curly bracket here is the same thing as adding together the values in my table here. So all I'm going to do for that curly bracket is add everything in this weight column. So the area under the curve is going to be half h, and h in this case is 3, multiplied by all of this curly bracket, which is everything in my table here. So I get 2 plus 2 multiplied by the cube root of 11 plus 2 multiplied by the cube root of 14 plus the cube root of 17. And I can put all that into my calculator in one go. And that gives me 20.8 to 3 significant figures. In part 2, it says, explain how the trapezium rule could be used to obtain a more accurate estimate of the area. Well, what we originally had was something like this, where between y0 and y1, we've got this trapezium here, and hopefully you can see underneath the curve there's this little bit of area here in between the top of the trapezium and the curve, which we're not going to count. So our area is actually an underestimate for this one. So I've put an extra strip in between y0 and y1. Hopefully you can see now the tops of the trapezia more closely follow the curve, so that would give us a more accurate estimate for the area. So you only need 3 words to answer this question. You could just put use more strips. The more strips you use, the more accurate your estimate using the trapezium rule will be compared to the actual area under the curve.